Hello everyone, in this video we will learn all about limits at infinity. To begin with, let's review about vertical asymptotes. Now, given this, what's the limit of 2 over x minus 3 as x approaches 3 from the right and from the left? Now, making use of the table of values, so if our x is 3, so again it will become undefined. Now, if our x is 5, it will become 1 because 5 minus 3 is 2. So 2 over 2, that's 1. If our x is 4, so 4 minus 3, that would be 1 or simply 2. So solving for the values here, we will get this one. So as our x approaches 3, so the value for y is increasing. Now, if our x is 1, this would become negative 1. If our x is 2, this would become negative 2. And substituting these values in x, we will get this. So graphing this, we will have this one. Take note, it's vertical asymptotes. It's located at x equals 3. So with this, looking at the graph or even the table of values, what's the limit as our x approaches 3 from the right? Our answer here is positive infinity. Now, the limit of the function as x approaches 3 from the left will be negative infinity. But if our x is exactly 3, the result here is undefined or it does not exist because it is asymptotic. Okay, next. This one, what's the limit of 2 over x minus 4 squared as x approaches 4 from the right and from the left? Now, again, making use table of values, so substitute 4 here, it will make the equation undefined. If our x is 6, 6 minus 4, that's 2. 2 squared, that's 4, that would become 1/2. If our x is 5, this would become 2. Substituting these values for x, we will get these values. Now, if our x is 2, so 2 minus 4, that's negative 2, then squared, it's 4, so therefore it's 1/2. If our x is 3, so 3 minus 4, that's negative 1, squared, it's 1, so therefore it's 2. Substituting these values, this will be the value for y. Graphing this, we will have this one. This is the graph for 2 over x minus 4 squared. So take note, the limit of the function as the function approaches 4 from the right, it is positive infinity. The limit of the function as the function approaches 4 from the left, it is also positive infinity. But as our x is exactly 4, the limit is undefined because it does not exist. Okay, next. This one. This is the graph of a second function. So with this, what is the limit of the second x as x approaches pi over 2 from the right? So pi over 2, it's here. Approaching from the right, so we look at from the right, and it is negative infinity. While the limit of second x as x approaches pi over 2 from the left, this will be our graph. So with that, that would be positive infinity. Now, if our x is exactly pi over 2, the result here is undefined or it does not exist. Okay, another. This one, find the value of c such that the limit of the second of x as x approaches c from the left is positive infinity. So positive infinity will refer to the graph going up. But if it is approaching the graph or c from the left, our value here would be pi over 2, or that's 90 degrees. Take note, this is only for one cycle. Now, this one, for the second one, it's the limit of second of x from the right. From the right, and this time it is negative infinity. So negative infinity, we will look at below the x-axis. So negative infinity approaching from the right. So still that is pi over 2, or that's 90 degrees. Okay, another. This one, so still second x. So positive infinity refer to the graph above the x-axis, approaching from the left, so that's 90 degrees. Now negative infinity approaching C from the left, so from the left, so therefore that's 3 pi over 2. Now second of x, it's positive infinity approaching from the right, that would be 3 pi over 2. This one, negative infinity but approaching from the right, this would be pi over 2. Now this one, what is the limit of the second x as x approaches pi? So take note, if it's exactly pi, the value here is negative 1. Now the limit of second of x as it approached pi from the left, it is still negative 1. Now approaching pi from the right, so approaching pi from the right, so still it is negative 1. So at this point here, the limit exists. Okay, next. Limits at infinity. Now, given this, the limit of 1 over x as x approaches infinity. So if our x is 0 here, this would become undefined. If it's 1, if it's 2, that would be 1/2. If it's 10, it's 0.1. If it's 100, it's 0.01. Now, this one, the limit of 1 over x as x approaches negative infinity. So if it's negative 100, so it's negative 0.01. Negative 10, that's negative 0.1. This would be negative 0.5. This is negative 1, but still this is undefined. Okay, graphing this, we will have this value. Again, this is the graph of 1 over x. Now, looking at this graph, what is the limit of the graph as x approaches positive infinity? So our answer here is 0. This one, as our x approaches, or the graph approaches negative infinity here, the result is still 0. But it will be different if I will ask, what is the limit of 1 over x as x approaches 0 from the right? So 0 from the right, that would be positive infinity. Another, the limit of 1 over x as x approaches 0 from the left. So from the left, that would be negative infinity. Okay, another. The limits of exponential, logarithmic, and trigonometric functions. So the limit of 2 to the power of x as x approaches infinity. So given this, if our x is negative 3, that's 0.125. If our x is negative 2, that would be 0.25. If our x is negative 1, that would be 1/2. If it's 0, then that would be 1. This is 2, and this is 4. Now, graphing this, we will have this value, or this is the graph of 2 to the power of x. So, looking at this graph, the limit of 2 to the power of x as x approaches positive infinity, it is also positive infinity. Now, the limit of this graph as x approaches negative infinity is 0. Okay, next. The limit of 1 over 2 to the power of x as x approaches 1/2. Now, take note with this, substituting x with the values here, we will obtain this one. Now, graphing this, this is the graph of 1 over 2. Now, with this, what's the limit of 1/2 to the power of x as x approaches positive infinity? That is 0. Now, the limit of 1 over x over 2 to the power of x as x approaches negative infinity is positive infinity, because this will extend infinitely at the top. Okay, next. What's the limit of the natural exponential function, or Euler's number e to the power of x as x approaches infinity? Now take note, the value for Euler's number is 2.71821, 281, and so on. Now, substituting it here, if we will have this value to the power of -2, that would be 0.13, -1, and so on, we will get these values. Graphing this will be its graph. So, the limit of e to the power of x as x approaches infinity is also infinity. Now, the limit of e to the power of x as x approaches negative infinity is 0. Now, the limit of e to the power of x as x is exactly 0, the answer here is 1. Because again, any number raised to 0 is always 1. Okay, this one. Evaluating limits of logarithmic functions. Okay, now given this, substituting x with these values here, we will obtain this. So this is natural logarithm of 0.1, natural log of 0.5, you'll get this. Natural log of 1, you'll get this, and so on. Graphing this will be its graph. This is the graph of the natural log of x. Now, as you see it, what's the limit of ln of x? As x approaches 1 from the right, the result here is 0. What's the limit of ln of x? As x approaches 1 from the left, it's also 0. Now, what is ln of 1? The answer here is also 0. So at this point, a limit exists. Okay, this one. The limit of the logarithm of x. So, substituting the values for x with this, we will obtain this values for y. And graphing this will be the graph of the logarithm of x. So, the limit of the logarithm of x as x approaches 1 from the right is 0. Approaching from the left, it's also 0. Now, logarithm of 1 is also 0. Okay, next. The limits of the trigonometric functions. Now, given this, what's the limit of sine x as x approaches 0 is 0. So, this is the graph of sine x. So, as x approaches 0, so it's here, it's exactly 0. The limit of sine x as x approaches pi, or that would be sine 180 degrees. So the result here is also 0. This one, the limit of sine x as x approaches negative pi, or negative 180, it's still 0. The limit of sine x as x approaches pi over 2, or that's 90, that would be positive 1. And the limit of sine x as x approaches negative pi, or that's negative pi over 2, or negative 90, the result here is negative 1. Okay, let's have this one, some special limits. Now, the first special limit is the limit of sine x over x as x approaches 0. Now, graphing this sine x over x, we will get this graph. Making use of the table of values, if we will substitute x with 0, that would become indeterminate. If we will substitute x by negative 1, so we will get 0.84. So how is this obtained? So take note the values for x here, it's in radians. So that would be sine negative 1 times 180 degrees over pi divided by negative 1, we will get 0.84. So we'll get this. Now, if we will substitute x with the rest of the values of x here, we will obtain this value. Now, with the other side, we will get this one. So, with this, considering the table of values and the graph, the limit of sine x over x as x approaches 0 from the right, the result here is 1. The limit of sine x as x approaches 0 from the left, it's also 1. So, most likely, the limit of sine x over x as x approaches 0 is also 1. another. Now, the second special function is the limit of 1 over cosine x over x as x approaches 0. Now, graphing this is the graph of y equals 1 minus cosine x over x. Now, making use of the table of values, if we will substitute x here with 0, we will get indeterminate values. Now, if we will substitute x here with -1, the result here is negative 0.46. Now, how was it done? So, again, the values for x here, it is in radians. So, that would be 1 minus cosine. Our x is -1. So, since it's radians, convert this. So, times 180 degrees over pi divided by -1, we will get this value. So, substituting for the rest of the values of x to the left of 0, we will get this one. Now, making use of the values of x to the right of 0 and substituting it in the equation, we will obtain these values. So, with this, the limit of 1 over cosine x over x as x approaches 0 from the left, it is approaching 0. And as we approach 0 from the right, it is also going to 0. So, with that, our limit then is 0. Okay, another. Now, the third special function is the limit of e to the power of x minus 1 over x as x approaches 0. Now, graphing this, we will get this graph. So, making use of the table of values, if we substitute x here with 0, we will end up with indeterminate values. Now, substituting x with -1, we will get 0.63. So, that would be e to the -1 minus 1 over -1. And substituting with the rest of the values of x, we will obtain this. Now, considering the values to the right of zeros, so for example, if we will replace x with +1, that would be 1.7. Now, given this, so what's the limit of e to the power of x minus 1 over x as x approaches 0 from the left? The result here is 1. Now, the same function approaching 0 from the right, it is still 1. So, with that, our limit there is +1. Okay, now let's evaluate the following limits. It's the limit of sine x over x as x approaches 0. Now, graphing this will be the graph of sine x over x. Now, making use of the table of values, if we will replace x with 0, that would become undefined or it does not exist. And substituting x with numbers approaching 0 from the left and approaching zeros from the right, we will obtain these values. Now, what if you will just solve it algebraically? How are you going to do it? So, again, with this one, the limit of sine x over x, so we will multiply it with 6 over 6. Why 6 over 6? Because we will target that our values here would be the same. So if we'll have 6x here, we will also have 6x at the bottom. So with this, simplifying further, this would become sine x, and 6 times x will get 6x, but our 6 here will remain as 6. So with this, we can have assign y as 6x. So that would become the limit of sine x. So that would become sine y over 6x over y as y approaches 0. Now take note, the limit of sine y over y as y approaches 0 is equivalent to 1. Now with this times 6, so the result here is 6. So with that, we can always counter-check with our graph. So, looking at the graph, approaching 0 from the right, as we approach 0 from the right, the value for y is 6. So the same thing with the other side, approaching 0 from the left, the value would be 6. So that's how are you going to do it. Okay, another. Okay, what is the limit of sine 2x over 5x as x approaches 0? Now, given this, we will multiply the entire equation by 2 over 2. So, simplifying this further, so 2 here as is, so multiply 2 here, but 5 transfer here, so that would become sine 2x over 2x times 2 over 5. So, take note, our target here is to equate the values here. If this is 2x, this should become 2x. So, with this, let y be equal to 2x. So, simplifying further, we will get the limit of sine y over y as y approaches 0 times 2 over 5. So, take note, the limit of sine y over y as y approaches 0 is 1. So, times 2 over 5. So, therefore, the result here is 2 over 5. Okay, next. What is the limit of 1 over cosine x minus 1 over x as x approaches 0? So take note, when we graph 1 over cosine x minus 1 over x, we will get this function. So take note, making use of the table of values, if we will substitute x with 0, so that would become undefined, or it does not exist. So substituting x with the value for x here, we will get this value. The same thing for the values of x to the right of 0. So this will be the value for y. So with this, if we want to solve it algebraically, so with this given, so multiply the entire equation by cosine x over cosine x. So take note, our target here is to obtain the equation 1 minus cosine x over x. So, with this, multiplying this, cosine x by 1 over cosine x, will get 1. Cosine x times negative 1, that's minus cosine x. And as is x and cosine x to the other side. Now, take note, the limit of 1 minus cosine x over x as x approaches 0 is 0. And 1 over cosine 0 is 1. So, multiplying this, the result would be 0. And take note, we can always counter-check this one. Now, given this graph, as we approach 0 from the right, our value here is 0. And approaching 0 from the left, still the value for y is 0. So that's how are you going to do it. So that would be all about limits at infinity.